Hello class, welcome to 11.2/3. This is surface area. So our objective is I can recognize that the surface area of a prism is equal to the sum of the area of its faces by using nets. Sounds complicated, but it's actually very simple. There's just lots of steps. So let's look at our vocab before we can jump into what and how we're doing it. All right, our first vocab word is surface area. So the surface area is the sum of the area of all the faces or surfaces of a solid figure. Let's draw a solid figure. All right, here's my solid figure. It's a very poorly drawn solid figure, but it's a solid figure nonetheless. All right, so the surface area is the sum of the area of all the faces. So remember, the faces would be, we have the very front of the face here. So this one in the front is a face. Then we have this one on the side. See, that's a face. Then we have this top one, which is a face. But we also have this one on the left, so next to the one in the front, that is also a face. We also have the back one. I'm just gonna go like this for the back. You can't really tell the color there. I'm gonna just do like this for the back, so you can still see the top. And then we have the bottom, which you can't even really see either. So they all kind of intertwine amongst themselves. So this is the bottom one. I'm going to redraw the front one again. And we'll just do this for the front. Can't really tell. But so how many faces do we have here? We have the front, which is A, this side, which is B, the other side, which is C, the back side, which is D, the top or the base, which is E, and the bottom, which is F. So the surface area is the sum of all of those. All right, so let's look at our think question. If I have this shape, so I have this rectangle here, and I want to wrap it. I want to cover all the surfaces, all the surface of this present. And it's 4 centimeters high, 6 meters long, and 8 centimeters wide. If I were to draw a net for this, remember I want to start like I'm unfolding it. Let's see what our base is. Well, we can see our bases are this top here. Actually, no, our bases are this face and this back face. So this is a rectangular prism. No, it's a square prism, because it is made of squares on the bases. So I like to start with the bottom shape. So the bottom shape is a rectangle. So I'm going to start by drawing my bottom shape. So this is my bottom shape. It's this one. This shape. Now I'm going to draw this one here. So it's on the right side. Should be labeling this as I go. So my first shape measurements were 6 centimeters and 8 centimeters. My next shape, the base, the side here is still 8 centimeters, but the height is 4 centimeters because I'm going up. So this is 4 centimeters. So I would have this shape, which is the top, and it's the same measurements because it is reflecting from that bottom one, and they're all parallel, so it's the exact same. And then I have this face over here, which comes out on this side. So it's still 8 centimeters, because the 8 centimeters is this bottom number. And the other side would be 4. I'm not done here because I need to include my bases. So I have this front base here, which is coming off of that bottom face. And so 6 centimeters will stay the same, but the height on it was 4 centimeters. So this will be 6 and this will be 4. And then it's the exact same thing for this back one here. So it's still 6 centimeters, because this is the bottom. And then the height going up is 4 centimeters. So now I have this net, and I want to find the surface area for this whole shape, which I've now unfolded to make this. Does this look like any of the shapes we worked with when we were doing area in chapter 10? Did we have any chapter where you had to find more than one area? It is now a composite figure. That's because now we're just finding the area for each one of these shapes, so we can label each shape. This is A, that's this bottom one. B, that's this one. C, it's the top one. This would be D, that's this side. And then we have E is this front, and F, which is the back. What do we do now? When we were doing composite figures, what did you do? You found the area of each shape and then did what? Added them. So that's how you're going to solve for surface area. So first you find the area for each, then you add. So let's give it a try. This is unlock the problem. All right, so I am going to start by drawing the net. So first I'm going to make this transparent. All right, so I'm going to start by making my net. I'm going to start with my bottom. Starting with this shape, and this will be A. So it's 12 inches. This line here is 12 inches. This here is parallel to this top number. So this is parallel to this. So the length of this side is 15 inches. All right, so I got one down. Now I got to get the other side. Let's go to the right. Now I'm dealing with this side. And this is B. So the side that they are sharing, the side that A and B are sharing, is this side here, because it is 15 inches long. So I need to draw coming off of that. So 15 is still on that side, but if I accounted for this side, these two sides, now I need to account for the bottom, which would be 10 inches. So this is shape B, this is shape A. Now I'm going to use blue again to do this top, which is C. And do you see that this is the side C and B are sharing? So it should still be coming off of this side here, because the 15 inches here is still the same. I'm going to quickly draw this 15 inches smaller because it is unnecessarily large. So all these sides are 15 inches. And since shape C and A are opposite from each other, they're going to have the same dimensions. So it was 15 by 12 for A, so it's 15 by 12 for C also. And now for this side, this is side D. And I'm going to do D coming off of A here. But I'm not done, right? I need to draw my faces. So I have this front face now, which is coming off of A here. And A and this shape, let's name it E, are sharing this line here, which is 12, but the other dimension is 10 here. So this would be 10 inches on the side. Then my other base would be in the back here, and this would be F. And it is coming off on the other side of A. And it is parallel to E, so it has the same dimension. So it's 12 inches by 10 inches. So now I have my net for this shape. Now we're going to solve this just like a composite figure. I'm going to find the area for each of these shapes. So I'm going to start with shape A, which, instead of saying shape, let's say face, because it is a shape, but a better description of it would be face. So face A's dimensions are 15 by 12, and it's a parallelogram, so the area for a parallelogram is base times height, and we're going to use that for all of these. So now I have 15 times 12. So 15 times 12, let's do it over here. 2 times 1 is 2, plus 1 is 3, 0, 15, 0, 5 plus 3 is 8, plus 1. So I have 180 inches squared, because I'm multiplying an inch and an inch. That's for face A. All right, now I'm going to find for face B. The dimensions are 10 inches by 15 inches. So I have base times height, which is 10 times 15, which gives me 150. Now I have face C, which is 15 inches. Oops, I've got my inches up here. So now I have 15 times 12, which I already did, so I know it's 180 inches squared. Next is face D, which is 15 inches by 10 inches. Which is 10 times 15, we did that already. It gives us 150 inches squared. Then I have face E. And the dimensions for E is 12 by 10. So I have 12 times 10, which gives me 120 inches squared. So face F is 12 by 10 also. So I have 12 times 10 again, which gives me 120 inches squared. Now, like a composite figure, we need to add all of these areas. So I have 180 plus 150 plus 180 again, plus 150 again, plus 120 again, plus 120 again. So let's add these. Got 0 here. I'm gonna do some quick mental math. So I have 8 plus 2, which gives me 10. Then 8 plus 2, which gives me 10. So I have 25, 30. So now I have 1, 2, 3, 4, 5, 6 plus 3 gives me 9. So I have 900 inches squared as my surface area. Because I found the area of all the faces and added it. All right, here are steps. So we're using the same example. And step 1 is to draw the figure and net if needed. Sometimes they will provide the net, so you won't need to do that. So I just copy and pasted what I had. Next, step 2 is to find the area of each face. So I'm just gonna quickly write, since we were doing, all these are parallelograms, so it's A equals base times height. So face A was 15 times 12, which gave us 180. Face B was 10 times 15, which gave us 150. Face C was 15 by 12. When we multiply those, we got 180 again. Face D was 10 by 15 again. So we got 150 again when we multiplied those. Face E was 10 by 12, which gave us 120 inches squared. And finally, face F, which was again 10 times 12. So again, we had 120 inches squared. What do you notice about these shapes and the areas in their dimensions? So look at the dimensions and the areas. Face A and face C have the same dimensions because they are opposing faces. So see how we have face C here and face A there. Next, we have face B and face D are opposing shapes or opposing faces. So here's B and here's D. They're the sides. So they have the same area. And finally, face E and face F have the same area because they are, yet again, opposing faces. So if the faces are opposing each other, then they have the same area. So we could have easily done this instead. So this is our hack. We could have said face A and C. So it's 15 times 12 for both of these, which you would get 150 for A and C. So that's 1, 2 shapes for that area. So what do you have to do to 150? Multiply it by 2 because there's 2 shapes with that area, which gives us 300 for those 2 faces. Next, we can say the area for face B and D, which was 10 times 15. No, it's not. Oh, silly mistake. $15 times 12 is 180. And when you multiply that by 2, well, 18 plus 18 is 36, so it's 360 inches squared. And face B and D have dimensions of 10 and 15. There we go. So 10 times 15 is 150 times 2, which we're multiplying by 2 because there are 2 shapes with that area, and that's 300 inches squared for those 2 areas. Finally, we have face E and F, which was 10 by 12. So when we multiply that, we get 120. There's 2 shapes with that, which would give us 240 inches squared, fairly fitting that in. All right, so our hack is opposing faces have the same area. Therefore, you can find the area for one opposing face, then multiply by 2. This will make it go a lot faster. Look how much easier. Well, if I had done that up here, I would have saved a lot of room because this wouldn't be here, and this wouldn't be here, and this wouldn't be here. They would be together with E, B, and A. So that's our hack. Now we can add. Let's see if the hack works. So find the sum of the area for each face. So now I just need to add them. So sum means add. So I have 360 inches squared plus 300 inches squared plus 240 inches squared. Since I'm adding, the inches squared stays the same. 0, 0, 0, 0 is 0. 6 plus 4 is 10. Carry the 1. 3 plus 3 is 6. Plus 2 is 8. Plus 1 is 9. So I have 900 inches squared as my surface area. All right, let's look at our examples. So example 1, we need to find the area using a net. So let's make a net. I'm going to start with this. I always like to start with the bottom number. I feel like the bottom face. Feels like it's the middle for me, but you can start wherever you want, right? So it is 3 meters by 5 meters. 5 meters by 3 meters. Next, I have this face, which is on the right side of that. And just by looking at it, I can see it's bigger, right? And the side that it's sharing with the bottom is 5 meters. So see 5 meters, 5 meters. And the other dimension is 8 meters. Next, I have this face, which I should be labeling them. Let's go through and label. This is A, C, and I'm about to draw shape C. This is B. All right, so the side that's being shared here is C, and B is 5 meters long. So remember, that doesn't change. This one will never change. But A and C are opposing, so it is 3 meters. Now I like to draw my final shape, this face, which is D on the left side because see, it's on the left of that bottom one I started on. And D is opposing to B, and I can just see here the side that's being shared is always going to be the same. So it's still 5 meters by the opposing figure was by 8 meters, and I can see it's 8 meters. Now the front bases, which is here. So that's coming off, it's coming off of, it's folding forward. So this is E. Since I'm imagining that this shape is folding forward, so see how it's folded forward? The shared side is here and here. So it's 3 meters, which we can see is still labeled. So then the only other side, it'd be going up, which is parallel here. So it's 8 meters here. And then this shape is exactly the same. It is shape F. It is parallel to shape E. So that means it'll have the same dimensions. So 3 centimeters, not centimeters, 3 meters by 8 meters. Now I can find these areas. So faces A and C are the same. So the dimensions for that are 3 meters by 5 meters. So I have 3 times 5, because remember the area is base times height. So 3 times 5 is 15 meters. And I have 2 shapes, right? I have A and C, so I'm going to multiply that by 2. Ooh, it's 15 meters squared. So 15 times 2 gives me 30 meters squared for face A and C. So for face B and D, which share the same dimensions, it's 8 meters by 5 meters. So I have 8 times 5, which gives me 40, times 2, because there's 2 shapes with that area, which gives me 80 meters squared. Then I have face E and F, which their dimensions are 3 meters by 8 meters. So 3 times 8 gives us 24. That's meters squared. And there are 2 shapes with that area, so we get 48 meters squared. Great and dandy, I have all these areas. Now I need to add them. So I have 30 meters squared plus 80 meters squared is 48 meters squared. So when I add these, I get 8. And I have 8 plus 4, which gives me 12, plus 3 is 15. So my final answer for the surface area is 158 meters squared. All right, that is it today. You can get started on your homework, and I will see the AM group first, then the PM group. So remember to join your AM and PM cohort groups, not the usual group A, group B. All right, I'll see you guys there. Bye.